The standard level of energy needed to split a water molecule for hydrogen generation has never exceeded 99% efficiency. Therefore, is a system claiming over 2,000% efficiency just too good to be true? Today, we're surrounded by technologies that were once considered too good to be true. However, individual opinions never stop these technologies from moving forward, generating commerce, and setting our current landscape. Due to current technologies, we must agree that there are natural energy sources and reactions that do boost energy or deliver free energy. For example, pockets of high and low atmospheric pressure causing air movement. Thermal energy from our sun, a natural energy harvested by solar panels. Nuclear energy may be categorized as a natural energy since it's energy obtained from heavy metals found in the Earth's crust. Heat, light, sound, and electric are all forms of energy produced in a lightning strike. A single bolt of lightning can release between 1 billion and 10 billion joules with a current intensity of 30,000 to 50,000 amps. However, the harvesting and storage of lightning is not a simple task. Galvanic energy is a form of electrochemical energy commonly revealed in batteries. Similar to nuclear, galvanic energy is provided through manipulation of metals found in Earth's crust. All these energy sources are naturally occurring and only require an apparatus to harvest. They are not to be confused with the theory of perpetual motion, where kinetic energy is somehow increased with reaction-free mechanical energy. They are, in themselves, a source of energy. H2 Innovation Lab has utilized one of these energies in a method of efficient hydrogen generation. The method outputs 22 times the input energy purely because of the natural galvanic energy enhancing the process. Just the same as nuclear reactions produces more energy than the energy needed to produce the reactions, and fueled by a source obtained from the natural energy accumulated in metals. Galvanic energy is the boost reaction deployed within this enhanced electrolysis method of hydrogen generation. But since the electrolyte is refreshed, this galvanic reaction does not die as do batteries. In conventional electrolysis, 1 part oxygen and 2 parts hydrogen is released. However, in this enhanced method, the released oxygen atom bonds with the preconditioned electrolyte to boost the galvanic reaction, increasing the cell voltage. In effect, the oxygen atom turns the cell into a battery to supply its own electricity. As the voltage increases, the process of water molecule splitting also increases, not only producing more hydrogen, but also more oxygen, which in turn increases the galvanic reaction.
Energy is not being created, which is impossible, but rather two energies are being transformed and combined into a greater energy. At some point in this demonstration, the fuel cell output reaches 1.7 amps at 47 volts, equaling 80 watts of electricity for an input of only 49 watts. To calculate the amount of energy generated by the electrolyzer under test, we must factor in the 60% fuel cell energy loss.
Yes, the fuel cell used to convert hydrogen back into electricity is only 40% efficient.
Therefore, divide the output 80 watts by 0.4, which equates to 200 watts of usable hydrogen energy for the 40 watts of input electrical energy.
That's an energy gain of 400%. Even if the fuel cell was 100% efficient, the displayed output readings are still higher than the input. How is that possible?
To illustrate, you may think that an automotive alternator generates power from kinetic energy only. However, that is not the case. There is in fact two energies needed for the alternator to generate the electricity to power a car. The bulk of the energy is kinetic, but this will not work without the second, electrical energy. From the perspective of input versus output electrical energy, there is an energy gain of 16. This is achieved by combining energies. The input electrical energy transforms to a magnetic energy to convert the kinetic energy into electrical energy. The combination of energies causes a greater output electrical energy than the input electrical energy.
I see. Therefore, in the H2IL galvanic enhanced electrolysis technology, the galvanic energy parallels the kinetic energy of the alternator. The usable input electrical energy parallels the alternator's input electrical energy.
Correct. Because there are two electrical energies combined in the H2IL technology, The viewer may only focus on the usable input energy and overlook the unseen galvanic energy, therefore concluding the science to be impossible. Because the only usable input energy is electricity, H2IL have stated more output energy than input energy to emphasize the magnitude and versatility of this energy technology.
The combination of electrical and electrical energy is unique and game-changing. It provides a method of energy generation that is not reliant on the kinetic force needed for conventional generators driven by steam, fossil fuel, and wind or water flow.
And it does not consume valuable landmass to accommodate solar panels and wind turbines. It generates clean, reliable energy day and night in all conditions and without the need for energy storage. It fits straight into the power grid without main power line upgrade needed to support common renewable energies.
That is game-changing. Scientists have endeavored to achieve self-sustaining energy through nuclear fusion for over 50 years, while H2IL have achieved this level of efficiency with such simplicity.
Energy combination at an ionic level is uncharted waters in mainstream science. When an atom is in a stable state, its strength requires brute force energy to manipulate. But when an atom is an ion, it is much easier to combine energies through redox reactions. The input electricity is just a stimulus triggering the reactions.
So if the main energy harvested is galvanic, do the metals providing the galvanic energy consume rapidly?
No. You could compare the life of the electrodes to that of a battery's electrode, which lasts many years of constant charge-discharge cycles. The technology does not split the water molecules using brute force electricity, which would consume electrodes. Also, the electrolyte is preconditioned to become an ionic substance, which becomes more anodic than the electrodes. The chemistry is quite complex, but accomplishing an energy combination at an ionic level means very little energy loss and ease of molecule separation.